Welcome, everyone, and thank you for joining us today. Today's topic is physical AI in the warehouse, from vision to autonomous action. And we all heard a lot about AI, like in the past 2 years, language models, chatbots, process automation. But today we're talking about something a bit different, and that is AI that doesn't just think, but also moves. AI that gives robots real perception and real decision-making and real autonomy inside a live warehouse operation. And the key question we want to answer today is what is actually working right now and what is still hype. And to explore this, we have two people who look at this from different angles. First one is Peter Skov, who is the founder of InnoScale, a first-of-its-kind innovation center physically embedded inside a live warehouse in the Netherlands. Peter has spent years bridging the gap between technology vendors who build this stuff and the warehouse operators who actually have to make it work on a Monday morning. And then we have Bas Dubbeldam from Fix Logistix. And Bas, he brings decades of experience in 3PL operations, supply chain consulting, and helping brands getting their logistic partnerships to perform. Bas has seen a lot of technology come and go, and he's here to ask the questions that operators actually care about. And just a quick mention of the Q&A section, because you can feel free to use the Q&A section whenever something pops up that you want to ask. And just put it in the Q&A, and I'll keep an eye open, and I will merge it in whenever it fits into the flow, or otherwise I will take it at the end. So just use the Q&A, put in your questions, and I'll keep an eye. And with that, let's start with the very basics. So Peter, physical AI, what exactly are we talking about?
So physical AI is actually the meeting of when the AI that we call the, let's say, normal AI, the digital AI, actually moves from the screens into our real world, and really make sure that digital AI and the physical world actually become together, and it actually start looking and feeling. So basically you fuse those worlds together and you use the same structure. So for digital AI, you use a large language model, LLM, and for physical AI, you start using video language action models. So it's not only know, but it can actually also action things. So it's a VLA. That's the base of it for what we have in the physical AI.
And Bas, as I mentioned, you spend a lot of time on the operator side. When you hear like a new buzzword like physical AI, what is your reaction?
Well, first of all, I'm a logistics geek, and I think it's really, really cool. It's so much happening in the world of AI and physical AI. It's really easy to get lost sometimes or blinded by the hype around us. But I think, a lot of people think it's just about, robots doing things in the warehouse with little hands and running around. But there's so much more in that realm, right? So I've been working on projects with AMRs, for vehicles that go through the warehouse, quality control, inventory control. Today, of course, we're going to talk a little bit more about the picking side of things. So one of the things that really take as a basis for all my analysis and conversations and projects is that technology is never the goal, right? The goal for me is there has to be a use for it. So when I see anything about technology in general, but about physical AI in particular, my first question is always, what is the ROI? If it doesn't solve a problem for me, it's just a science experiment.
Yeah, I just want to put in. This is actually not something we prepared, but let's see, because I'm thinking as an integration guy. I'm from Bizbrains, and it's not a secret that we work with integrations, and we have our our platform called Link that can move data from A to B and back again. And I'm just wondering, physical AI, is that dependent on data the same way that other kinds of AI? Because you see a lot of posts on LinkedIn and so on these days with, yeah, it's good, fine with AI, it's all good and well, but how about data? If you don't have the right data at the right time, then you cannot really use AI the way it's meant to be. Is that also the case with physical AI? And maybe Peter, you could, because I know you are also big on integration and data, maybe you could just say a few words.
Yeah. So basically, it is. So basically, but it's different information. So what you have digitally is just numbers and letters, but actually to be able to have something that's visual and actually to be able to action it, you need to see here. So basically just see the item. You need to read the service, so honestly feel the service. And also you need to figure out how to grip and how to adjust. So it's so much more than just what we're seeing. So, what we have in cloud, for instance, or ChatGPT. You really need to be able to feel much more, have much more information, different kinds of information to be able to actually to grip things correctly. So actually be able to everything we see in our people in the physical world, what we see our brains with our eyes and our hands, you need to be able to do that. So it goes so much more than when you just read a book, because cloud is just like reading a book or writing down your answer on a paper. This is actually really feeling the whole thing. So it goes much more. So basically just all these four things here.
Yeah, okay. And when it comes to data, then I guess there's some other issues around moving like images compared to moving, as you mentioned, letters and numbers. Bas, you had a hand.
Yeah, I think for me, for maybe for the precise functioning of physical AI, some data exchange may be necessary, but for the use case of AI, it has to integrate in all your business processes. If you have a standalone machine that is very good at picking something because it can see and it can feel, it's just not useful information or useful instructions. It has to become part of your broader business process, your warehouse management process, and this is where integration really becomes essential.
Okay, yeah, I get the picture. Thank you, and sorry for going off script.
No worries.
Back to the script, Peter. You mentioned the vision as the defining layer in warehouse automation. Please elaborate.
Yeah, so vision is basically what we see with cameras, but also you need to be able to read that camera. So you need only not to see, but also you need to interpret what you're seeing to be able to use it and give it onwards. So that whole structure of computer vision, machine vision has grown so much. So we've got 2D cameras, we've got 3D cameras now, but also we've got super brains that is able to actually read that and use it. So all those things, so basically everything goes to what we have. We have ear, we have eyes, we have brains, we have arms, and we have hands. And actually, those things need to work together because they are in physical AI. They are all separate components, and you need integration between what you see tells to the brain has to tell to the arm, and then you need to have a 6-7 axis gripper that will be able to pick things without crushing it. And so this is actually very important to have that vision and that dexterity as well. So it's an example. So how do you, for us, it's very simple to actually change how we pick a lipstick or a glass jar, or actually more challenging, a water bottle. Because nearly all vision cameras will just actually not see the water bottles. And so how do you tell a gripper to pick something that he can't see or can't define? Same goes with a bag of screws. Where you pick the bag, because it's in plastic, you see the screw, but you need to actually pick the plastic. And how do you pick a shoebox, for instance? Those things are challenging, very easy for us, but it's very challenging to actually learn to see it, to interpret it, and give it on to somebody else, something else to be able to pick it. So that's really that central nervous system. That is really what we are seeing really coming up. And this is basically the structure of what we call physical AI currently.
Mm-hmm.
So some of the examples what we have right now, I know Dennis and I, we're Danish, but we also have good stuff even north from us. So Civit is a Norwegian company. They really make some of the best cameras right now to be able to see structures and be able to figure out what it really is. I got an example in a moment, but also Nomagic in Poland. They're actually really good at what they're doing right now because they're the first one who actually can physically pick up a shoebox. So as an example here is to see the picture. So it's a point cloud, what is called a point cloud. So actually those things, without being able to have it, they would all be plastic bottles that you can see through. So without being able to create that point cloud, you don't know where to pick. Normal old cameras would just see through all these glasses here, all these plastic bottles here. It's really important to be able to see it and be able to tell it in the point cloud what it really is. So you really get a true to reality point cloud where you can really use it to pick. And this is what the Civit is delivering right now as an example. Another example is the shoebox picker. It sounds simple, but we actually know it when we think about it. A shoebox, the lid can open. So it's not this thing you get when you get something from Amazon because all those parcel boxes are closed. This one is open. So how do you pick it up? Because you can't take it on top, because if you pick it on top, the shoes will fall off. That's not handy in automation. So those are examples of really things where we actually starting seeing that physical AI is really starting delivering on both the computer vision side and the gripping side.
Yeah, interesting. Bas, from an operator's perspective, well, when you have to, when you're asked to evaluate a vision-based system like the ones we just saw here, what are you looking for?
Yeah, so the thing that's always tricky is that I think, as Peter's already shown me, it's never one system, right? So there's a lot of, companies that make really good tools and components of larger environments that are actually out there, and they work together. So when I look at physical AI, I don't look at, is this the best shoebox picker or is this the best camera? I look at it as a stack. For me, it's an AI stack. And if you look at the, sort of different applications, for instance, the Civit, as Peter mentioned, that's how you see. The Civit sees the object. Then you have platforms like Visor, for instance. I mean, they understand, so they take the signal of what they've seen, and then they do something with that information, and then you have to act. It's the see, understand, act. I think that we touched on that earlier. That's the combination, right? And then it also needs to fit in a bigger environment. So systems like a Cognex, OneVision, these are systems that actually bring all the information in a larger, environment where we're training the systems, where we're integrating the systems, where we're, making different components of the network work together. And this is also when you scale, because if you just have some nice, sort of high-tech specialized machines, it's hard to scale that if you don't have the business process that integrates all together. So when I look at from that perspective, I actually typically ask myself a few questions, right? And it's always centered around how do you fix your operating problem? So one of the things is when you look at the technology, you also want to know, can we implement it without, making a mess, without disrupting our operations? I mean, there has to be consideration for that. The other question I would ask is our company ready to do so? I mean, are we okay maybe to do a small pilot, but is our data structure, our business process ready and organization also ready to absorb this rather complicated process? Of course, we talked about ROI. That's always a big point for my evaluation. And then also it's, as in all AI, and I think we had in other webinars, we've talked about it. It's, there is the nice design area for technology, but then there's also reality in a warehouse. Warehouses are not always, as clean and well organized as they should be. So you have to deal with what they call the brownfield reality. There's legacy things going on in your operation. That means that you have to also be able to deal with that, right? So it's not just the technology itself. So it's a combination of technologies together, and how does it fit in your operation, and then does it fix your problem? I think that's how I evaluate physical AI.
Yeah. Let's move on to as I mentioned in the beginning, this question of reality versus hype, which is always the case when something new shows up, and definitely is also the case right now with AI. So Peter, if you had to separate what is actually production ready today from what is more like a roadmap promise, what would you say?
So the vision picking, just like we saw the no magic thing, but also what comes from right hand and +1 robotics, they're really out there. They're actually starting doing it. And the one thing, and we also saw in the latest financial reviews, actually for Fanuc and Universal Robots, they're actually starting making money because of physical AI, because all the old robots that are out there can actually get a new brain, just like FSD now being put into Tesla. So suddenly some of the robots that did not actually have a good ROI, they are much better. And you actually see Fanuc and Universal Robots selling a lot of robots right now. So robot arms is really good right now. And also what we see from Pfizer OS, for instance, actually being able to depalletize and unloading. That's all those things that we see, multi-SKU pallets, unloading of containers. They are really the physical AI. We are really starting to see it because you see more and more of those companies coming out. But also computer vision for quality control and error detections. Right now, we are using smart cameras right now to do dimensioning. We used to do a cubic scan, a physical structure. Now we use a Keyence or a Cognex or whatever camera to do dimensioning. 100% correct every single time. But also AI-enhanced AMR notification. So we are starting to see actually smart solutions that work without SLAM, but actually what they see from a camera with AI, you can start really driving around with just having normal cameras, standard cameras that are much cheaper than a LiDAR, for instance. So you start seeing them come out as well. And of course you have what's agentic. So reading your emails for you, entering your emails for you, but also doing a lot of things in the EMS, WMS or EAP for you. So that is really out there right now. What is getting out here is the different humanoids. So don't think about Unitree because they are good at dancing, but not working. But actually what we see for Figure and 1X, especially Figure, who's already in the warehouse, we actually started seeing them actually getting up to the speed of people. That doesn't mean a return on investment. Actually, what we did see it a few weeks ago. So I'll come back to this slide here. But for instance, this one here, 1,246 orders per hour is actually really, really good. And it's the same speed as a person. So it's nothing bad about it. But you see the same process here for +1. They double that thing with a robot arm. So yes, a human is really getting there, but they're not as far as the robot arms right now. So yeah, when you want to do a return investment, the +1 robotics is cheaper to buy than a humanoid. But the humanoid is not doing bad. It's one of the first really good examples where we really see a humanoid being able to really deliver. And it's not old, it's 2 weeks old, this test here. So it's really good. So it was actually not there when we started talking. It actually came out in the meantime. So coming back, the humanoid is really good at doing things, but he needs to do specific things because it can't be as flexible as we are. So that's also one of the discussion right now. Everybody expected humanoids can go out and replace people. They cannot. And going at, we need to start developing things that really will be able to be as adaptive as we are as people to be able to have humanoid going in. But also very important, we are starting to see full autonomous goods to person. They're coming out there, which we call lights out warehouse. But we have very, very few right now that has been built with a return on investment. Sometimes they've been built, but it's just to have them, not because somebody would took a lot of money. But what we're also seeing is the NVIDIA dynamic digital twin. Actually, we're starting to see the way we develop things, how we simulate things with NVIDIA. So no, NVIDIA is not just a company building computers. They actually really have smart software. So really be able to see whatever happens in the warehouse, be able to react on it proactively. So this is what they're building for NVIDIA. So it's good progress they're having, but it's not there yet fully. And still high, well, SKU autonomous picking of SKUs all over everything in a warehouse. No, it's not going to happen within the next 3 to 4 years to 5 years. So for instance, if you listen to Boston Dynamics, they say their Atlas will not be able to be effective until 2030. So they're going to give it specific actions in the Hyundai warehouse because Hyundai is the owner of Boston Dynamics. But it's going to be very specific cases. It can go out to do more cases, generic work, but it's not until 4 years from now. And having fully utilized warehouse everywhere with an investment, well, we're somewhere between 2030 and 2035.
Okay, thank you. We have a question from Sudasan, and thank you for that. I will actually just postpone it a bit because it fits better later on. But let that also be a reminder to everyone to just put your questions in the Q&A. It's very much appreciated. Here was another one. I'll read that in a second. I have a question to you, Bas. Working with the operators on a day-to-day basis, what is the most common misconception around physical AI that you encounter?
Well, I think the most common misconception is that it's about robots with hands and feet and a face, right? I think, and we talk to somebody about what you do for a living, and you say, well, I'm in doing logistics and physical AI is something I do as well. Then they always have this picture of robots and like humanoid robots. But as Peter was already saying, humanoids are cool, and I think they're definitely going to be a future for that. But that's a misconception we should not really get distracted by, right? Because the robot arm that Peter mentioned, for me, that's a good example of that's a robot. That's something that really adds value to your operation. But probably more practical. I think one of the misconceptions you see in projects is that when we talk to a customer and we're having conversations about the strategy around AI and physical AI and warehouse automation and all these things, I think the temptation is that people say, well, let's go do this, and then let's organize a project. And I think the key thing is to realize that it's not just a project, right? I mean, if you want to be successful with automation, AI, physical AI, you got to see it as a different way of doing business. It's an operational turnaround that you have to commit to and have to really invest in, and as an organization, get behind it from top level to down. So I think it's important to realize that, right? So if you don't have the strategic intent and then also really the will to do this, it's not going to be something. It's not just a project that you start and it's done. Another misconception, I think, is that when we talk to customers, they always want to shoot for the moon, right? It's they think that if we go into AI, physical AI, we have to really do the whole place. The whole warehouse has to be, transformed into something bigger and better. And sometimes, there's a sense for that. Boston Dynamics actually had a project with them that they were unloading trucks with physical AI with a robot arm. And then as a result, their dock got congested because they didn't think about the put away process behind, right? So it's definitely you have to make sure that your processes can absorb it in the right order. But, it's not necessary to really think of, let's design a complete large warehousing operation that, that is fully managed by physical AI. I think still, I want to go back to what does it do for me? What is the return of investment? And that means you got to understand where's your bottlenecks. And if you have a bottleneck somewhere in receiving, then that's where you invest your effort and time and money. If it's in picking, then that's where you go, right? So I think it's totally okay to target specific processes where you think the biggest bottleneck is, what problem you can solve with what tool, and then what's the return on investment, does it make sense? And then go all in on that.
Yeah, okay. Actually, I think, Bas, that this question from Christobas is actually good at this point. And he says, has AI and its implementation advanced enough to have off-the-shelf solutions that would be able to do Q&A and Q&C for unloading, taking visuals off the pallet, counting the number of products on the pallet, understanding what product it is, and pinpointing any damage that is physically visible. For this would then be integrated with automated storing systems. Bas, starting with you.
Yeah, no, absolutely.
Off-the-shelf solutions.
It's they're there, and it's there's still a variety in how good they are. But what you see right now, and this actually came from some of the people that do drones that fly in warehouses and with cameras on them. First, they started just observing a barcode or a written alphanumeric code, but then they became smarter. The cameras became better. They started looking at, let's also take a picture of each pallet. That's for not only for inventory counting, but also count how many boxes are on that pallet. The next question would be is, how's the wrapping? Is it intact? Other quality issues. I mean, I've seen projects where we would do big bags, big sacks that actually would sometimes not sit right on a pallet. You can train AI to do that as well. So if you have the visual camera that actually can capture all this stuff, then there's all kinds of ways of doing this. And the funny thing is that in inventory management, this for one point was going to be the holy grail, we thought, right? That essentially what happened there is that inventory counting, inventory control is actually too late, right? I mean, it's all you're trying to find things that are off. So the new trend there is actually that instead of just flying around or driving around with a camera on a stick or on a drone, you actually start saying, well, let's bring the process forward. Let's start avoiding those issues. So right now, some of those companies that are engaged in that, they actually go into making, when it comes off the truck, there's a camera on the forklift, and that actually captures the pallet as it comes off, or the boxes as they come off. Then if the forklift picks it up, it also, when it puts away the pallet in a location in the rack, it also captures that the pallet arrived at the rack. We put it in its location. We capture the location. Now we're real time, always sure that what we received is in that location, is in good condition, wrapping was intact, all that good stuff. So yes, I think this is going very quickly, very fast. It requires, a very mature process. So I think here also comes the question we talked about earlier, that you have to be ready to do this. If you have a bad item master, for instance, you cannot do the put away correctly and these other things. So there's all kinds of other things coming well, but definitely this is a very much happening technology right now. And you can buy them more or less off the shelf, but you got to integrate them into your operation.
Yeah, and actually to pick up there when you integrate with the operation, because we have a very good question here from Sudarshan, because it has to do with errors. So let's say in a 3PL or partly automated warehouse, most of the operations are handled by human operators. Physical AI can identify problems or errors, but the operators have to follow up and solve the problems. So, and that's the question. So how does understanding physical AI convert errors into action items for operators to fix? And I don't know if Peter or Bas. Peter?
So actually, errors that has been caught by Cognos, for instance, they are actually not physical AI. They are machine vision. So it's needed to be able to figure it out, but there's no automation behind it. So you need to be able to sense it. So what we quite often do, we would quite often use a Cognos or keyings with some LED lamps. So basically showing where you did things right or wrong. So this is how we try to make that, let's say, thin physical AI. When you do something wrong, so we did it with Cognos, something come down a conveyor belt, chutes, and we need to put into 3 or 2 or 4 different things. And we actually, with a camera and a LED lamp, we showed it was right or wrong. Very simple, because then you actually directly see if it's red, it's wrong, and you need to look and, okay, you put it over here, it is red. So we tried with that structure to actually show it very smartly with LED lamps in combination with computer vision. And we do the same thing, for instance, in Toronto, where we saw with a lot of paint on the floor. We actually put a combination of computer vision and lasers out there. And we actually, with laser, we made the floor. And we could change the floor with something difficult or heavy moving around. We changed the lighting on the floor in it. But it's not physical AI officially, it's machine vision. And then we just use the LED lamps, also part of machine vision, to actually show things. So how we try to help them do it, but physical AI is actually automation. So this is where we need to give it over to a hand or a humanoid. But so last time we can have the discussion later on.
Bas?
Yeah, so I think, the relationship between humans and machines is, of course, a very important discussion. There's a big statement, all people talk about the human in the loop. And I think, when you find, the more you use physical AI and camera technology, especially with the technologies Peter was just describing, I mean, you're almost not going to miss anything. And the problem is that if you don't do anything with that information, things go wrong. I mean, we had people deploying very good camera systems for the inventory accounting and warehousing, for instance. And if a drone flies around your warehouse every day, and every day it tells you pallets 1, 2, 3 on rack 4 is either damaged, or it's not complete, or it's in the wrong location, and you don't actually escalate that and fix that, then the information, you just get the same information about something is wrong every day. So I think the way we do projects is we always make sure we don't believe that AI is the end goal, or physical AI. It has to be managed by people. I think also when you don't allow people to have the final control about the process, it's very hard to get it accepted and successfully implemented. But it's the relationship between humans and AI and physical AI. I think it's important that it enhances the quality, so it's a better tool for the people that actually are responsible for the warehouse, and I think that's what counts in that relationship. So I'm hoping that also helps with the answer.
Yeah, I think it does. Otherwise, please let us know in the Q&A comments. Yeah, there's a lot of good questions here, and I also have a few still left on my paper here. So
let's go.
So I think, that's very nice and interactive. So I think we should actually just move on with a question here from Cecilia, and I'm just going to read it out loud here, and it goes like this: the robots and AI get all the spotlights, but what are the most commonly overlooked prerequisites? Whether that's network reliability, floor quality, data quality, process standardization, or systems integrations that end up determining whether an automation project succeeds or fails. I think we already covered a bit of it, but just to make sure that we get all the way around, let's just take a. Who wants to?
I think Bas already said it, but the base is data. Because data is the only thing, is the same thing for every single project you have, whether you only have WMS. And of course, the processes will change. So whether you are doing loose or on the end of a sorter, but the data still has to be right. If you don't know the data, you can't let a lamp go green or red. So, but you need to be able to have the data to be able to do your processes. And the data should be of good enough quality, but also giving the right details to tell anybody, because whether it's a person or a lamp, it does not matter. If you can't say A means B or A means C, nothing will happen. So the data is the most important thing. And actually the data that sits and talks to each other. So apples and pears is one of the biggest problems we have. If somebody calls it a shipping number and somebody calls it an order number, they're not the same. When they might be the same, but I don't know what it is, whether it's the same. So it's the only generic thing you have all over. That's why all digitalization, actually with data management, is the base of all automation projects.
Mm-hmm. Yeah, but that kind of makes me happy as an integration guy, because then we are back in business. That's good. So
with that one, data on the right time at the right place.
Yeah.
Just having the data, using it doesn't help.
I hope, Cecilia, that this, together with what was already said before I read your question, answers your question. Otherwise, feel free to reach out afterwards. We will send the contact information, and feel free. You're very much welcome to write to any of us if you need further clarification. So moving on with the script, and this one is for you, Peter. And I've often heard you talked about the difference between 90 and 99% uptime as the real battleground. And so I'm just curious to hear from you, what does it actually take to bridge that gap from 90 to 99?
A lot of right quality and a lot of money and a lot of training. So here in automation, we talk about going from 90 to 99. That's already a challenge for automation. In my old world, we had a discussion about 99.99. And we had to uptime at WMS for 99.99, and it was not just for one warehouse. No, it was across the whole world for 1,000 warehouses. And let's come another thing. So that's the life of WMS automation. We just need now to go from 90 to 99. But it's very important because if you look to a warehouse like where I was yesterday, we do 50,000 orders a day, and 90 sounds good, but it still means we have 55,000 not going well. That's a lot of fixes for people. So it sounds like small, 90 is okay, yeah, but okay for budget, but not for real thing. It really, really has to be 100% correct or very close to be able to do it. Also coming back, automation will not have a return on investment until you get to 99. So operations have to be there, and there's also something that the startups and scale have to be diligent about. Our solution need to be at least 99% quality before they're sellable and usable by 3PLs. Very important. So 90 is really good. It's a great number. It's great, but it doesn't work. It doesn't get you into the area where warehouse really work, because 90% is just not enough. We really need to go to that 99% to be able to do it. So it could be failures in perception, it could be failures in the brain when we talk about physical AI, it could be main issue of having the right vacuum pump in an arm or the right gripper. If you don't have the right gripper, you can't grip correctly. So all those things are important to have in the stack that Bas is talking about. We will know that if you don't have the right data or the right quality in what you do, well, in every single part of the stack, things can go wrong. Just like we are one person, but yeah, there are 5 parts in the standard physical AI stack, and really every single thing has to be at 99%, not just the arm or the gripper. Every single thing is also important and challenging, because in that stack, they all normally come from 5 different partners. And you need to make sure that those 5 partners all are above 99%. And that's actually the challenge we're seeing right now. A lot of the components are 99, but not all. So this is what we basically see all over right now. And one of the issues for Go humanoid is a battery or an actuator or whatever. So that's the challenge in getting that whole stack up to 99. So those are the things right now that people are waiting for right now to finalize the business case and really be able to go from POC to real operation. This is why people are doing lifestyle warehouses, but putting a lot of money in there. There's no return on investment in it. But coming back, it still is important doing it, because without really challenging it, without testing it, you will never get better. This is also why we went to universities or whatever. So we train for playing in the World Championship. You won't get to the World Championship without training. So we still need to have that effort to be able to learn people to get to 90 and bit by bit move them up to 99 and eventually to 99.99, just like MSC.
Thank you. Anything to add, Bas?
Yeah, no, I think that makes sense, right? I'm just, as an operator, if I have 90% accuracy in different tools, and I multiply the 90% by 90% by 90%, I mean, I'm really getting to a level that every operator will get a nightmare, right? So I think it's important to realize that Peter is at the bleeding edge of tech. Right, so these are really nice picking systems with both vision and dexterity. This is like the future, right? I think some of these things are good, some of things are still being developed, and I think the 90% is where you don't want to be. I think the other 9.99% is what Peter and his guys will be working on. But it's also good to realize that this is not the only physical AI there is out there, right? I think there's a lot of simpler technologies that do perform, and Peter showed them in one of his slides what's hype, what's not, right? I think it's important to realize it's not all scary and things go wrong still. No, a lot of things go really, really well, and I'm excited about that. So.
Okay, and the final question from me, that's for you, Bas, and that's from a practical standpoint. As an operator, what should you do to get yourself ready for physical AI?
Yeah, so I always think that it's important, and it's back to my opening statement also, right? It's about return on investment. You have to fix a problem, but you got to know what your problems are. I think it's important to understand your operations, and we always like to start off with some benchmarking when we talk to an operator and say, how do you compare to your peers? How do you compare where you want to be? Do you bleed somewhere? Is productivity down, or you have a lot of errors? I mean, these are the kind of things you want to identify first, and then there's going to be a before and after thought, right? I mean, you want to make sure that you understand what you have, what you don't have, and where you want to be. So I think that is the single most important item for any tech project, for any AI and physical AI project, is identify what you want to be achieving, and then manage that also. So once you start going, you have to make sure that you have your KPIs defined, so you can actually track progress. You're still on track, doing the right projects. Other than that, I mean, I think Cecilia was who asked the question about, the data in order, processes are standardized, ownership is established. We talked about human in the loop. All these things, are important to be ready for your operation, right? So if you don't have those, boxes marked, you're going to have problems. So first, know where you want to be, what you're going to do, define your purpose and objectives, then find the right solutions, solving those problems. But to solve these problems, you need to have your house in order with some of the other things we talked about.
Thank you. And let's finish, because we are a little over time, and we already covered a lot. And thank you for the great questions. Very much appreciated. I think that was a nice touch to our otherwise scripted program. And thank you, Peter and Bas, for your perspectives. And let's do it again. I feel we have a lot to talk about. So maybe a follow-up, and everyone keep an eye on your inbox for the next webinars, and see you. Thank you, everyone.
Bye-bye.
Bye-bye.